Morning, dear students. Hope you are doing well. You are listening classes regularly. And I told you in the beginning itself, if there are any doubts, please contact me through phone or message or any mail. See here, today we are going to discuss the continuation part to the previous class. When we have a look what we discussed in the previous class, we are at groundwater sources. Before we are going to discuss today's session, I would like to brief the topic what we discussed in the previous class. See here, we are discussing the sources of water, where we have finished surface water sources, and now we are in the name of surface water. We just discussed three subtopics: the name, lakes, rivers, and impounding reservoirs. Hope you understood the difference between these three sources fall under surface water. Now we just move to the groundwater sources, and even the reservoirs we discuss more elaborately the topic, the criteria to be considered when we are going for constructing reservoirs. And there we also discuss a comparison of water on its quality and quantity as part of your curriculum. And also we discussed how we can calculate the storage capacity of proposed reservoir and what are all the factors to be considered when we are going to propose a reservoir. And now we enter into the groundwater, the topic. We have discussed, and we are going to discuss three subtopics. The name of groundwater. Actually, we have seen three subtopics as part of surface water. Similarly, here also we are going to discuss three subtopics in groundwater. We have seen the first topic, springs. The previous class, what is spring, what constitutes spring, and what are all the different factors that makes the water to come out from the surface of the ground. See here, of course, there are different types of springs. We are, as part of curriculum, as part of syllabus constraint, we have discussed almost 6 or 7 types of springs more elaborately with the diagrams. Dear students, when you are going to write an answer for this question, you must learn these diagrams also. Apart from your explanation part, you must also write, or you must also draw these diagrams, then only you'll get the good marks. Only by defining what is what, that is not a meaningful sentence. You must draw the diagram also. All right. See here, we have seen the types of springs: stratum spring, overflow spring, valley spring, fault spring, deep-seated spring, solution channels, and we just discussed more elaborately what is the ABCD of these springs. Now we just entered into the topic, wells. I also given the brief introduction for these wells. See here, wells here and there, and from your childhood onwards, you used to hear the word wells. See here, it is an excavation. It is an excavation that is created to meet the requirements of water demand. Earlier days, there is no public water supply. People used to depend on these type of wells, rivers, and lakes. We have seen what is lake, what is river, and what is reservoir. Now we are going to discuss what is well. So it is an excavation that is created in the ground. How? by digging. By digging, we are just making an excavation by digging for what? To collect the water for various requirements. Based on the depth, these wells can be categorized into different types, or they can be categorized into different categories. The first and foremost thing we are going to discuss here is percolation wells. Maybe you know what is the meaning of percolation. The literal meaning of percolation is nothing but, see here, water will get percolated into the deep soil. In the same way, we may be observed the infiltration, absorbing, percolation wells. See, what is this? What is these percolation wells? When we have a look over there, these are the shallow wells. Shallow, that means minimum depth from the surface. These are the shallow wells. Mostly they are confined to sand, gravel, and soft gravel. These are restricted. These are confined to what? Up to sand, gravel, and soft gravel. And the diameter of these wells may be between 1 meter to 4 meters, and probably the depth will be up to 22 meters, depending on the requirement, and also depends on the geological conditions. One more time, see here, the diameter of the well may be up to 1 meter to 4 meter with a depth of 20 meters, maybe a little bit, approximately up to 20 meters, maybe little bit higher than 20 meters, depends on the requirement as well as depends on the existing geological conditions. Probably, and these are mostly suitable for small discharges. Here, these wells may not suitable for the water requirement where huge scale people are dependent. These are meant for to meet the minimum requirement where the water discharge is restricted to up to approximately up to 20 cubic meters per hour. See, if the requirement is more than this, you may not depend on, you are not supposed to depend on these type of wells. There you must go for other types of wells. What are those other types of wells? We are going to discuss one after one. Probably now you may get an idea what is this percolation well. See, these are confined to soft ground, and the width is about up to 1 meter to 4 meters with an average depth of 20 meters. That will depend on your requirement and geological conditions, where the discharge is approximately 20 cubic meters per hour. So this is about the diagrammatic representation of percolation wells. See here, percolation wells, how we can construct, how we can make this. I said that wells are nothing but an excavation that is created in the ground by digging. How can you or me can make this type of percolation well? Simply, I wrote everything on the on the slide itself. I mentioned here precast RCC blocks, bricks or stone masonry. What? Precast RCC blocks, bricks or stone masonry will be used for constructing these type of wells. What we are going to use? Precast bricks, RCC blocks, bricks or stone masonry will be used to construct these type of wells. The depth of the wall may be, I said that 20 meters, maybe the requirement, based on the requirement, it may be a little bit higher, and we can go for up to 75 meters, sorry, width up to 75 centimeters, the width. See here, for the construction of these wells, what we can do, simply a curve, a circular curve, which is made up of either RCC, else in wooden material or any brick masonry material, upon which masonry work is done up to 1.5 meters height. Again, I'm coming back. See here, the construction of these wells, a curve, a circular curve, which is made up by RCC or any wooden materials, even that can be made up with brick masonry up to an height of 1.5 meters. Shovels are used to dig the soil, to excavate that from the inside of the curve. Shovels are used to lift the soil from the curve, and once we are lifting the soil from the curve or as from inside of the curve, based on the weight that slowly moves downwards, and it will be continue up to the depth as per the requirement or as per the desired height. Once we reach the desired depth, A parapet wall will be constructed over the well after completing complete sinking of well, and even we can provide a shelter or else a roof can be prepared with pillars to avoid the contamination of well water. See here, a curb is placed. Around this curb, soil, the soil will be digged out with the help of shovels, and it will be continued till the desired depth. Once we once we got confirmation that this depth is good and this depth is suitable, we may stop digging soil, and around this soil, around this well, the parapet wall will be constructed. Even we can provide a shelter to avoid the water contamination. This is about percolation well. Simply percolation, what you are observing everywhere, this is about the percolation well. And here is the water table. This is water level. From here, this is surface. From here, you are started digging soil. Once you reach to the desired depth, where you can observe with the with moisture content, where you can sense the water level up to that particular depth, you can dig. And I said that earlier itself, it depends on geological conditions. Geological conditions is here with respect to this percolation wells, nothing but observation of water content. Once we got confirmation that we reached the water table, we'll stop the digging of soil, and a parapet wall will be constructed against the digged soil, and even a roof will be provided to avoid the water contamination around the or else above the well. And next one is, see, these wells are restricted to to meet the small requirement of water demand, where these are suitable up to 20 cubic meters per hour. If the requirement is more, then we may go for other type of wells, that is driven well. You and me regularly used to observe at our homes, driven wells. Driven wells in the sense, these are more suitable for individual houses. The main objective of this driven well is to meet the requirement of individual houses. A casing pipe is introduced into the ground, which has the perforated linings. Perforated lining in the sense, nothing but holes. See, you may be observed once we are at your homes, before you are going for hand pump. See, a perforated lining will be introduced into the deeper ground, and it will be introduced into the deeper ground either by hammers. If the depth is more, we may be used water jets. You and me are regularly encountering all these type of all these type of wells. The other name is nothing but hand pump in our local terminology. See here, what is the basic thing before you are going for driven well is, these are mostly suitable for individual houses and to meet the requirement of water exclusively for individual houses. See, a casing pipe will be introduced into the deeper ground. At the bottom of the casing pipe, a perforated lining will be given. For what? Not for decoration purpose, or not for some other purpose. Only the purpose is to avoid the entry of soil particles into the tube or else into the pipe. That is the reason once you are trying to get the water from hand pumps, you cannot absorb soil particles mostly. See, because the perforated lining is acting as a barrier to avoid the entry of soil particles. See here, the percolations are covered with a screen to avoid, I said that, just soil particles. And even based on the requirement of the depth, you may opt for hammers or else you may opt for water jet. What is the requirement? If the depth is up to 50 meters, you can go for hammers. If the depth is more than 50 meters, there is no other way, you should go for water jets. See here, this is the schematic diagram of driven wells. See, by seeing this diagram, you may be observed that this is what you and me are regularly observing at homes, right? See, this is the perforated lining tube, what we are introducing into the soil, and it is covered with seeds to avoid the entry of soil particles. I said that in the first case, that is restricted to the discharge where the requirement is 20 cubic meters per hour, whereas in this driven wells, the requirement is exclusively suitable and meant to meet the water demand of individual houses. Now, when we have a look at the third category, that is tube wells. Now we are here, don't get deviate. We are discussing about groundwater sources. Under groundwater sources, we are discussing about wells. Wells has been categorized into three categories. Number one is percolation well. The second one is driven well. Third one is tube well. What is this tube well? In the first case, the requirement is 20 cubic meter per second. Here, if the requirement is more and up to and these tube wells can meet the requirement at the rate of 200 liters per second with an average of about 50 liters per second. Now you can imagine the performance of tube wells. Whereas the percolation well capacity is only 20 cubic meters per second. Here 200 liters per second with an average of 50 liters per second. And this is what, and the tube wells are more playing vital role nowadays where the quantity is more or where the quantity is huge. See, again, these tube wells can be categorized into four types. Wells are categorized into three types: the percolation wells, driven wells, and third tube wells. Again, these tube wells subcategorized into four categories. See, the first one is strainer tube wells. Here, strainer tube wells in the sense a blind pipe will be introduced into the ground based on the requirement. See here, before we are sending this pipe, we are started sending this pipe into the deeper ground. An experienced person will get the data of that particular area geological conditions. He will note down. He will note down once the pipe is being introduced into the soil, up to what extent, what type of soil is existed at that particular area. Once he got the data of soil, see here, as per the data, he will introduce the pipe with perforations. See, once all the perforations will be covered with the soil, covered with the sieves to avoid the entry of soil particles. Again, see what that geologist is doing here. See, once that there is a confirmation that percolation wells and driven wells may not meet the requirement to meet the water demand. In such cases, there is no way we should go for tube wells. In the tube wells, again, it has been categorized into four categories. First one is strainer tube wells. In this category, while the blind pump is being introduced into the soil, the data of the soil will be noted down by the analyst. Data of what? The data of different soils to which the pipe is going to be introduced. Based on the data, the pipe will get the perforations will be given to the pipe. To all the perforations, a screener will be provided to avoid the entry of soil particles. See here, now you'll get the picture. Now you'll get the brief imaginary scope to your minds. Here, this is about the strainer tube wells. Here, this is blind pipe. Once it is being introduced into the deeper ground, the different strata of the soil will be noted down by the analyst. See here, this is an impervious layer. This is confined aquifer. This is impervious layer. That means here, once the pipe is introduced into the ground, the perforations are given. Based on what? How can we know that perforations has to be given here itself? Because while the pipe is passing into the ground, the perforations are given as per the depth of the soil bed. And we are confirmed that at this particular depth, the water aquifer is there, because while digging the tube into the deeper ground, we got the confirmation. Based on the confirmation, the percolations, the perforations will be given to the tube. After giving the perforation, a screener will be given to the perforations for what? To avoid the entry of soil particles into the tube. See, once we started pump, the water will be entered into the pipe from all the beds of the perforation. That is the reason the water quantity is more. That means the water will be discharged not only from one particular aquifer, the water will enters into the tube from different aquifers at different depth. Why? Because we have given the perforations at different depth as we got the data of the soil while we are pumping, while we are sending this pipe. This is about strainer tube well. That is why the rate of water discharge for tube wells is approximately 200 liters per second with an average of 50 liters per second. This is about the strainer tube well, and the next one is cavity tube wells. The name itself revealing to us is there is a cavity where the cavity, see here, this is the cavity. This is the cavity, and see here, see one point is these are most common tube wells to lift the water from the subsurface of water table. See here, from where the water is lifting from the subsurface of water table. See, a pipe with perforations will be introduced into the water table, which is near to the surface. All the perforations are covered with coconut or jute mesh to avoid the entry of fine soil particles. See, in the earlier case, we just covered, the perforations are covered with the screens. Here, the perforations are covered with what? Jute mesh to avoid the fine soil particles, and these are not fit for consumption actually. These are used to fit, or these are used to water the constructional, what for watering construction materials. Understand? Once again, these are mostly common, these are most common tube wells where the water will be lifted from the subsurface. A tube will be introduced to the required depth. Perforations will be given based on the data what we have, from where the water will be entered into the pipeline, and all the earlier case we have seen the perforations are covered with screens. Now here the perforations are covered with jute materials, jute mesh to avoid the entry of fine soil particles, and mostly these are used to watering for watering construction materials. And these are see here, and this is about the this is about the cavity tube well. Cavity tube wells here, sorry, perforate, I mean these are most common to lift the water from the subsurface. See, this is about the perforated tube wells. See, perforate introduced the water table which is near to the surface with copper. This is about the perforated tube wells, and it is mostly suitable for watering of construction materials. Perforated tube wells restricted to subsurface, and the the pondering points are here. The jute mesh will be given around the perforations to avoid the fine soil particles, and these are meant to meet the requirement for the watering of construction materials. This is about the blind pipe, and we are introduced up to only subsurface depth. These are the perforations. All the perforations, see here, are covered with jute mesh to avoid the entry of fine soil particles. The next one is cavity tube wells. See here, cavity tube wells, these are uncommon. These are uncommon for geological conditions, and in this method, a tube well introduced into the ground to many of aquifers. See here, the tube has been passing from different aquifers. In the strainer tube wells, the tube is passing different aquifers, and we are noting down the data. Based on the data from all the water containing aquifers, the water will be introduced into the tube, as we have given the perforations with screener. Now here, even though pipe is being introduced into the different strata of the ground, the water will collect only from the bottom. This is what the difference between the strainer tube well and cavity tube well. See, cavity tube well, and this is water will be introduced into the tube only from the cavity that is made at the bottom. Whereas in the previous case, the water will enter from all the aquifers to which the pipe is being sent. See here, the cavity, and that is, see, these are most uncommon for Indian geological conditions. A tube well introduced to the ground through many of aquifers. See here, a screener at the bottom act as a barrier to avoid the entry of fine soil particles. See, in the earlier case, at all perforations will be given at all the aquifers where the water tables are existed, and the screener will be protect all the perforations. But whereas here, the water only enters from the cavity. That is the reason a screener will be provided at the cavity itself, because water is entering into the tube only from the cavity. That is the reason. There is no meaning to provide screener at all the water bearing aquifers, because we are not collecting water from all the water containing aquifers. We are collecting the water only from the cavity. That is the reason the screener will be provided to the cavity itself. Hope you understood. Hope you got the information, the basic difference between the strainer and cavity tube well. See, we discussed about the perforated tube wells, and the next one is slaughter tube wells. what is the slaughter tube well and what is the ABCD of the slaughter tube well. We'll go once we examine the diagram, then we'll move to the explanation. This is about the slaughter tube well, where a casing pipe initially will be introduced into the ground, into the deeper ground. Once, see here, these are, see here, they consist a large casing pipe driven into the bottom of available water table, from which slotted iron pipe will be introduced till the bottom. See here, first initially a casing pipe will be introduced into the ground in the sense up to what depth, till we'll get the water table. Once we identified the water table, iron rod pipe will be introduced till that particular water table, and that the see a casing pipe initially introduced. Into that casing pipe, an iron rod pipe is introduced. That means you maybe imagine that there will be a gap between the wrought iron pipe and the casing pipe. The gap will be filled up with what? By using the material called as buzzry. This type of arrangements, technically we used to call it as shrouding. What we used to call it as shrouding. See here, this is an, after sending this pipe, compressed air will be introduced into the pipe to avoid the, or else, see, I just mentioned here, see here, one more point I wrote here. See why we need to send the compressed air, in the sense to take away the soil particles from the tube. See here, the iron pipe consists an arrangement of sending compressed air for purification of settled particles. We'll discuss more elaborately one more time. Up to here, we are discussing about the wells. See here, this is about the case. This diagram clearly speaking to us. This is a casing pipe. I mean, in that we are introduced a main pipe. To the pipe, compressed air is being introduced. See here, the area between the wrought iron and casing pipe, gravel is filled up, or gravel or buzzry, which is called as shrouding. The water will be lifted from this iron water pipe, and to avoid, or as to avoid the settled particles, the compressed air will be introduced into that particular wrought iron pipe, and from here water will be collected. This is about the slaughter tube well. Here we are today we discussed about the wells. In that we have seen the first category, percolation wells, second category, driven wells, third category, tube wells. In these tube wells, the difference, and we may opt any of these wells based on the requirements. When the requirement is more, we'll go for tube wells. In this tube well, we have seen 4 categories: strainer tube wells, cavity tube wells, perforated tube wells, and slaughter tube wells. Next topic we'll discuss in next class. If you have any doubts, you please make a call to me, or you can give the mail or message. Thank you.